Welcome back to the Aussie Shed, ladies and gentlemen, for another episode of Project Fairlady. So, as I alluded to in the end of last week's video, I'm still working on the shifter, but I've now moved on to the bushing section here on the bottom of the shifter that goes onto the shift fork that then runs into the transmission. So what I'd like to talk to you about is bushings for this. Now you can still buy the factory bushings for this shifter, which I have a set of right here. So this is the factory arrangement. You have a shaft that runs through the middle of the bushings here, and then the bushings are pushed onto this section here of the gear stick, and then a bolt runs through the center and your shift fork clamps onto the outside. The force that's applied clamping this is governed by this bush that runs through the middle, or this shaft, this axle, whatever you want to call it, so that the factory shifter rod is clamped up hard against this edge, and that gives you enough clearance for the bushes to move around on the inside. So what you have here, the point of rotation on these bushes is on the inside. So as you can see here from the wear on these shafts, or on this shaft, that is from the bush spinning on that. It remains fairly stationary in the bottom of the shifter because it is a tight fit, and it rotates around that area there. And it is allowed to do, like I say, move freely because the shift fork clamps hard against the outside of this, which gives you enough clearance for that to rotate. The problem with the factory setup is these plastic or nylon bushings. They might even be Teflon. They're very thin and they don't really last a long time because they're living in a very harsh environment under the car. There's all the heat from the exhaust system, etc. It's just not a nice place to be. So it doesn't take very long before these start to break down. When I pulled my shifter apart, these were basically non-existent. There were just fragments of them trapped sort of between the casing and between the shaft there. So you end up in a situation where you get a lot of slop. So what's been done about this in the aftermarket is they've created a bronze bushing set that you can buy instead of the factory bushings. And the aftermarket bushings that you buy look something like this. The shoulder's a bit thicker. This is just one of my offcuts from the bushings that I've been making, but that is pretty much a good representation of all of the aftermarket bushings that you can buy. It appears to me that someone's come up with this design and everyone else has just copied it. I looked at using these bronze aftermarket bushings and also buying a set, which I have done, which was my first initial purchase of a set of factory replacement bushings. Neither of which I was happy with, and I'm mostly disappointed with the aftermarket bushing set that everyone seems to sell and most people seem to use, only because it's the only thing available. Now, I'll outline what my problems with this style of bushing are. Now, firstly, it is a tight fit on the bottom of the shifter. When it goes into here, you have to hammer it in or press it in. So once the bush is in, it doesn't rotate on that part of the shifter. I'll just zoom in, guys, so we can have a bit better look at this. Here we go. I'll grab this out, bring it a bit closer to the camera. Okay. So as I say, the aftermarket bushings that you buy, they are pressed or pushed into that, and they are a very, very snug fit. So the situation that creates is that because that is now not a movement point, the rotation or the axle part of this bushing as it moves becomes the bolt. Now, the bolt that goes through these, the factory bolt, it's an 8mm bolt. So you now have reduced the surface area that the bush moves on by half. So by halving the surface area, you've doubled the amount of wear that it is exposed to. So what they've done even to make this setup operate is all the kits when you buy them either have a nylock nut included in them, or they tell you to use a nylock nut instead of the factory nut and spring washer, which clamps it up tight. And the reason being is you can no longer clamp it up tight when the shift fork goes over the top of this, because the reason for that is that if you clamp it up tight, then the bolt can no longer turn. So the way they've gotten around this is by telling you to use a nylock nut on there and leave it loose so that you get movement here. So in the instructions for all these different kits, they tell you to leave this loose, and they tell you to sort of move your gear stick around until you find that it's not binding, and then that's where you leave it. Now, I really don't like that setup. Like I say, we've reduced the contact area by half, and we're now relying on a nylock nut that is loosely attached to the end of this bolt. It's an area where there's a lot of heat and a lot of crap going on, and as good as nylock nuts are, the thing that they really don't like is heat, because the nylon becomes soft and they no longer do their job. So having something that is fairly inaccessible held together with a loose nylock nut is not really the sort of thing that I would like to do. Alright, so I said to myself, surely Trevor, there's got to be a better way. So I've been working on this for a while, trying to come up with a better design, something that's well thought out and covers all of those bases. What I've come up with is what I call my version 2 design, because it really is just an improvement on the standard bronze bush design that is sort of freely available. So firstly, what I've made my bushes out of is this stuff here. This is called LG2. This is a bronze bushing material. It's commonly known as leaded gunmetal. It's a bronze with a high lead content in it, and it is one of the bronzes that is specifically used for things like bushes, etc. So, let me tell you about my design. So what I've done here is I've kind of incorporated both elements of this. I've basically duplicated the kind of factory setup. So if you look at that and you look at mine, you'll see similarities. But the axle on mine is actually incorporated into the bush instead of the bush sliding on it. So what that means is that when you bolt this together into the bottom of the shifter like that, these two ends actually butt together like so, and they're machined to a very precise tolerance, so that when the shift fork goes over the top of this area here and you put the bolt through and clamp them together, you can actually clamp it together tight, and it pushes these two hard together, and then the clearance is maintained on these outside edges here, as I say, because it's set by the overall length and these two guys here. So what I've done with this, I've set it up with a 0.25mm clearance on one side. So that's the total end float is 0.25, and that's due to the variance in the size of the bottom of this piece on the bottom of the shifter. It does appear that the shoulders on the side have been machined, but I feel that there will be a difference between shifters just because of the age of the vehicle and the different amounts of wear that they've had. So I've left 0.25mm on the ends of these so that it is very, very easy to file fit these bushes to suit your individual shifter. Now the diameters on these bushes are precisely machined as well. They should fit most shifters. The only time you'll have an issue is if your shifter has been very, very poorly maintained and has wear on the inside of that piece of tube there, which isn't normally the case because, as I say, with your factory shifter, the wear point is on the axle shaft, not on this section here. However, it's something that you can't sort of discount, but I honestly don't think you would have any amount of wear that would mean there was a large degree of slop on these bushings, because, as I say, they are a close tolerance machined fit, so they do fit in nicely, but there is no movement, or very little movement. And what that also means is that because of the way that this is done, then the rotation of the bush compared to the shaft is no longer happening through the bolt, through the centre, because it is done up tight. Rotation is now moved to the outside of the bushing, which basically doubles the surface area compared to the bolt method on the aftermarket bushings that everyone kind of runs nowadays. And brings it more in line. It actually exceeds the surface area of the factory setup. So, I've got a few diagrams here, guys. I just thought I'd show you this. So what I have here is representations of the different bushings. So if you can just bear with me, consider this to be the tube on the bottom of our shifter there. So that round bit there and that bit going back, that's looking like that on there. Okay, so that is that. Okay, so we're all good with that. Okay, so this is a representation of the way the factory bush works in here. So you have this axle shaft that runs through here. That's the grey section there. We have the bush, which is very thin, that slides over the top, and that is the red area here. So that red area represents the inside of the bush. So that is the area of motion. That's where the two areas slide against each other. And the surface area of two of those bushes together adds up to a total of 93.5 millimeters square. So that's the total bearing area of the factory style bush in the end of the shifter. Now, what we go to here, this is the standard current aftermarket bronze bush setup that everyone is using. So the red area again through here, that is again the point of contact between the two surfaces, and that is the area that the parts slide around on against each other. Now the area on this is 55.2 millimeters squared. So you can see it's slightly more than half of the factory surface area, but basically it's reduced it by half. Now the third diagram, the green one, so this is my version 2 bushing that I've made here. My bush has the highest surface area of 110.57 millimeters squared over the factory's 93.5. Now that's achieved by the fact that the factory bush rotates around the inside of its diameter, and mine rotates around the outside of its diameter. But basically there's very little difference between the surface area of them, mine being ever so slightly, and honestly a negligible amount larger. But again, the bronze bush that everyone's using is basically half. Well, there you go, it is. It's exactly half of what mine is. 110.57 compared to 55.2 for that. So what that really means is that there are two things. There is the premature wear side of it, because you only have half the surface area, but there is also the wheel or axle size. So guys, if you've ever pushed something with small wheels across some uneven ground like a trolley, and you know how hard it is to push it along a surface compared to something with big wheels, okay, how easily that glides over a surface. And it's exactly the same situation when you're talking about a bush that's rotating around a bolt of 8 millimeters through the center, or a bush that's rotating around 16 millimeter diameter, which is the outside. It's much easier for that to turn, and it's a it's a much smoother arrangement, and an arrangement which will last a lot longer. So I thought, okay, well this is great, this solves all these problems for me. I've just got to be able to machine these bushes accurately, which I've managed to do. I'll go into that in a little bit more detail. I had to upgrade my lathe with some bits and pieces, and I also made many prototypes which have ended up in the bin for various reasons. What I'm also doing with this setup is I'm making it greasable. What I'm going to do is drill a hole in the back of the gear stick here, and I'm going to mount a grease nipple in there, which is part of the reason why we have that recess there, why I didn't bring these bushes through at the same diameter all the way through, and that's so that it clears the grease nipple on the inside. Now the grease nipple is something that you don't have to have in there, but for me it means that once these bushes are installed in this shifter, that it's a set and forget thing. If occasionally if you want to grease it, it's fairly easily accessible from inside of the vehicle. By taking the cover off the back of the stick, you can get through and get a grease gun fitting on the back of there quite easily, or you can actually get up to it fairly easily from underneath by reaching over the tail shaft. You can quite easily feel where this area is, get a grease gun hose on there and just give it a few pumps and it should be good to go again. So I'll just go to some footage now that I just shot of when I was making these up. I already had them turn, and I've just been doing a little bit of the sort of precision work on them to fine tune them to their final sizes. So what I'm doing here, guys, is some final sizing on these matched bush pairs before they go into one of the more final processes, which is being shifted over onto the mill to have some vertical slots put in them to carry grease throughout the bushing as they run. So these have all been done on the mini lathe with a DRO, and they're pretty close to being exactly where they need to be. But because of the nature of this sort of bush, because it is actually solid, you need your end float to be very precise. Now, to me it looks like we've probably got about 0.3 of a millimetre there, end float on that. So what I'll generally do with these is I'll give them a bit of a rub on a file over here to make sure that there are no burrs on them. I'll bolt them together at a rough working torque, which is where they'll be. Just snugged up, they don't have to be super tight. And then we'll give them a bit of a measure. So these sets, I have them set from between 30.7 millimeters and 30.8 millimeters. And this, at its smallest measurement, it's about 30.8. So it's, you know, it's pretty close. That one is actually pretty close. I may actually take it down a little bit. I might take 0.05 off one of these bushings, just to make it a little bit tighter. The reason being that 0.25 is very little movement side to side on these bushings, but some folks might want to get it down even more. But I'm assuming that there is a little bit of variance in the end of the shifter here. They do appear to be machined on either side, but depending on you know, service life and wear, etc., we may find that there is a little bit of variation in what everyone has. So I want to leave 0.25 on there so that you have a tiny bit that you can work with if you want to take it down even more and make it even a little bit tighter. But it's very simple to do. So taking off 0.25 with the file is very, very simple. As I've been doing over here, just get a fine file, don't use anything really coarse, and just sit the bush on like that and just rub it backwards and forwards a few times, and it'll only take a few strokes to be taking off amounts that will get you down really fast. But I must say, just be careful that you don't go too far with them, because if you do go too far, then the bushes won't butt together properly when they're bolted, and they'll start to bind on the sides. And if that happens, really that then is you're in the opposite boat up here. You just have to just file a tiny frag off the outside of here. Now these are generally, from what I've seen, these can be a little bit daggy anyway, so it would pay to, once you get the remnants of your original bushes out of here, run something through there that's not going to take too much meat off, whether it's like a wire pipe cleaner type thing. You get all the crud out, because there will be heaps of crud in here, and you'll probably have a few burrs around here, so you just carefully need to get some files and whatnot and try and clean up any burrs or anything on here, because if there are any high spots, you'll be in a situation when you hit that high spot, it's going to bind. So you want to make this, you know, all the shoulders that are on here as smooth and even and consistent as possible, so that you can get the best, most precise outcome that's going to maintain that kind of precision in the shifter for as long as possible. Yeah, I feel this is definitely the best way to do that. I'll just head over on the mini lathe, and I'll take maybe 0.05 of a millimetre, so 5/100ths of a millimetre off one side, to bring it back into where I really want it to be. Alrighty, so there we go. Gets us down to 3075, 3076, 3075, which is bang on in between 3070 and 3080. Alright. We'll check it one more time. So we've still got rotation there. We'll grab our feeler gauges. And we can just squeeze the 0.25 feeler gauge in the side there. So that's spot on. That's the end of the sizing for this pair. So 2 pairs to go for me in this stage, and then I'm ready to move on to the mill and start cutting some vertical grooves in these guys. So this is a setup that I've created on the mill for just running the 3 vertical lines that are going to carry grease down in these bushings onto here. So this is a 6-inch rotary table, and I have a 5-inch 3-jaw self-centering chuck mounted on that. And in the middle of the chuck, I have a piece of 25mm mild steel round bar that I've drilled and tapped on the lathe with an 8mm thread. And I'm going to be using that to hold these bushes so that I can mount them identically each time, and use the mill to drill down with an end mill. I'm using a 4mm end mill on here to cut the grooves in the side of these bushings. Now this setup allows me to repeatably do the same thing every time. The rotary table is graduated, so I can divide 360 degrees into whatever I want with graduations. I've got every 120 millimeters marked on the thing, so that gives me 3 holes, obviously. How this goes together, you just sit the bush on there, run this bolt down through here. Again, the hard thing with these bushes is finding a way to be able to mount them flat and perfectly square, and in this situation get it done without being in the way of the cutter that's going to be coming down and doing this. So this is what I came up with, just a simple thing. Use the rotary table, make this sort of boss underneath to mount these into, and I'll bring this in a bit closer. Let's knock some holes in it. What's better, that or that? Very hard for me to tell. I really need a better camera, guys. This is terrible. I think that's possibly better. Maybe. There. I don't know. Alright. Anyway, I'll just give you a bit of a quick squiz of how I do these. And like I say, you can see from this jigged setup that each one will be identical. And that's that. So as I say, this one comes out, next one goes in, they all end up exactly the same. We get a repeatable, precise component. And there it is. Let's head to the bench, and I'll show you how it looks with a set of them made up together, attached to the gear selector. So there's the one that we just did. So this is basically a mock-up of what we will have in there. So you got your 2 bushes, 3 grooves in each one. They will then be fitted into the shifter like so. One there, bolt through. Actually, that's the wrong bolt, don't like that bolt. So I am supplying a bolt and yes, a nylock nut, but it's not used the same way in my kit. The nylock nut that I'm supplying is done up tight, and it's all stainless, so a stainless M8 bolt and a stainless M8 nylock nut, which is again done up tightly. And the reason that I've done these is so that I can use a bolt that has a long enough shoulder to reach both halves of the bush, so there's little chance of it kicking around like this when you're on the threaded section, because the threaded section is looser than the shouldered section. And you can see even from this socket head bolt here, it's M8, that the shouldered section is shorter. So I've managed to get these stainless bolts. I may actually have to slightly cut them down before I package them in with some sort of a kit with these things. But it's really just to, again, maintain sort of precision of that axle line, so that when the bushes are bolted in, you don't get one that's kicked slightly and wants to jam inside the shifter housing there. So anyway, this is our setup here. So there's our 2 grooved bushes. They go in. Your shifter fork bolts on the outside. Bolt goes through. Nut goes on. Do that up tight and it will still move. Okay, so even with it done up tight, you'll still have movement there, and you should have 0.25 millimeters, which I've been setting with this feeler gauge here as I've been doing them. See there, we've got a neat 2.5, just squeezes down in there on each of these sets as I do them. As I say, if that's too much movement for you and you're interested in purchasing one of these sets, you can very easily file the end of this down until you get the clearance to what you want it to be. But believe me, 2.5 or 0.25 is a very tiny amount. As I say, this isn't finished. That's far from the last step with all this, guys. These bushings have to have one more thing done, and that is this. Each bushing now gets 3 holes. Focus, baby. 3 little holes drilled in the end of it. You can see that. Compared to that one, holes, no holes. So both bushings in the pair get 3 holes in the end of them, and they're 2 mil, those holes. And you might say, well, Trevor, what the hell are those holes for? Well, let me explain. So this is a center bolt, and it has had all the final stages of machining work done to it. So it's now been machined on the top, drilled down through there to that point, and it's been drilled and tapped to 6mm in the head, and I don't know if you can see, but a shoulder has been cut around the bolt where this hole is drilled through, and as I say, that hole connects to this hole. And basically what I've done is sort of turn this into a banjo bolt. And the reason we have this 6mm hole in the top is where our grease nipple screws in. So in the kit this will come with the grease nipple already fitted and Loctited, and there's also a rubber cap for the grease nipple. So when this is assembled, what we end up with is, when we have our gap here for the material on the edge of the fork linkage, that then brings one of these holes, or the holes on the bush closest to the grease nipple, it brings those over the top of the slot and the hole in our bolt. So when grease is pumped down into this bolt, it will then feed out through these holes, and if the holes don't line up exactly, that doesn't matter. That's why there is a groove cut around it, so grease can flow around the groove and then out the holes. And the reason I've done both of these is so that on assembly it doesn't matter which one you put on first. So either one, they're both identical and they both will line up with the hole. It just takes that margin of error out of the assembly process. If I only drilled one, then you know, there's a chance of putting them on in the wrong order. You go to grease it, nothing happens, and that would be why. So that's basically the finished assembly there. That's how it will come, like this. Some of you might look at this and say, that's ridiculously over-engineered, Trevor. And you'd be right. But it's unfortunately just the way I roll. So what we'll do, I'll mock this up in the bottom of the gear stick there, and I guess we'll have a crack at pumping it full of some grease and see what happens. I'll just have to get some washers or spacers on the sides to mimic the fork linkage, just because if I don't do that, then the grease holes won't line up properly. So I'll grab something, probably just a washer. We'll get it mounted on the bottom of the gear stick, and we'll suss it out. We'll just snug this guy up. Still got nice rotation going on there. Beautiful, guys, absolutely beautiful. Now, all that's left to do is pump it with some grease. So I'll just try and get the camera in as close as I can and sort of change the orientation of everything, just so you get a better view. Right guys, that should be a reasonable position there. Let's get the grease gun on and pump some grease through this thing. Now, just for a bit of transparency, this is actually the second shot of this, guys. I've already pumped this with grease, and the reason being, I did a nice demo for you guys, then went to move the camera at the end of it and realised I hadn't pushed record because I'd been frigging around beforehand, and I've been turning the camera on and off and thought, yeah, it's all good, but I'll do it for you now. But grease will come out straight away, even though it only took really 2 pumps before the grease came out. But it'll probably come out on the first pump, I reckon. Get this bloody grease gun on there. Alright. And I shall give it a couple of pumps. And as you saw, grease just starts pouring out. Okay, and as I mentioned before, there will be a grease nipple cap supplied in the kit. Whack it on there, and you're all done. And I guess that's probably the end of the video, guys. So as I say, if you're interested in getting hold of this kit here that I've made up, I did make about an extra 10 sets of these when I was doing them. I will put them up for sale on my website, upperhandperformanceproducts.com.au, where all the Aussie shed stuff goes. And as I say, I've only got 10 sets. At this stage, I'm unsure whether I'll be making any more of them. Cost of materials and all the frigging around, all the bits and pieces involved in it, it's probably not worth my while to make any more. Let's just say it wasn't really a money-making exercise. But if you're not interested in that, I would quite honestly say that the factory bushing is a very, very well designed piece of gear. In my opinion, leaps and bounds ahead of the standard bronze bushing set that you can buy from most aftermarket suppliers. The reason being, this is a very well designed product, where just your standard bronze bushings are a very poorly designed product. And as I mentioned earlier, the only real issue with the factory setup is it doesn't have a very high service life. But again, if you want something with a super high service life that once you've got it in, you'll never ever have to touch it again, it'll remain tight and precise through the entire rest of the life of the vehicle, then this is the thing for you. Alright, I guess we better leave it there. As always, guys, thanks for stopping by the Aussie Shed. Always a bloody pleasure to have you here. If you like the video, give it a thumbs up. Remember to subscribe to the channel. And as always, I'll bloody well see you on the next one. Cheers.